Okay guys, here's your first video of the year. We started this morning with, in 1.1, we're looking at real numbers, functions, and graphs. We started with the real numbers, interval notation, absolute value. That's as far as we got. So we have to do graphing, functions. The rest of it is a bit long, so this might be one of the longer videos of the year. I'm just warning you. So I'm trusting that you guys know how to plot points. If you want to look at page top of page 4, I mean, you can look at the quadrants, the rectangular coordinate system, and the distance formula. I'm not going to go over that because I think it's probably been pounded into your heads. I do want to, however, address circles really quickly. If I have a circle centered on AB, some radius R. The equation of that circle is as such. X minus a squared plus y minus b squared equals r squared. Yeah, that comes directly as a result, actually, of the distance formula. It's pretty neat how it's developed, but that one I don't know if you've mastered yet, so I wanted to give you a little primer. If the center, let's say the center is at 3, 3, which this one is, and the r is 2, you're going to have x minus 3 plus y minus 3 equals 2 squared. Okay, so that's the prime example there. Function. In the past, we've just said for every x, there is one y. Okay, we're going to make that a little bit more formal. You're going to formalize quite a bit of stuff in this class. You might want to get used to the language and the structure of it. A function f from a set D, your domain, to a set Y, or your range, is a rule that assigns each element in X in D to a unique Y, which is a function of X in Y. We could write it as that. Okay, that's a capital Y. So the function takes the domain to the range. Each element, you have an X element in here, it takes it to a Y in there. Okay. It's just a little bit more formal. It allows us to do some proofs and stuff, which we need in math to be. So, remember again, D is, remember domain, X values, range is the Y values. Okay. Thing you got to remember though, this is what we call an allowable input. Okay. So if I have something like f of x equals the square root of x, negative numbers are not allowable inputs there. So the domain we're probably going to see a little bit of notation change here. This is a set of x such that x is greater than or equal to 0. So it's 0 or bigger, positive. Okay, the range, again, is going to be the set of y such that y is greater than 0, because that's the output and the input. Okay, so what can I not put in there, or what can I put in there? Let's look at something like g of x equals 1 over x plus 1. Okay, well, we know the bottom cannot be 0, the denominator. Right? So if x is negative 1, that's 0. So we know the domain, set of x, such that x is not equal, x is an element of the reals, and x not equal to negative 1. Okay, the range, set of y, such that y cannot equal 0. And you can put that y is an element of the reals, and y cannot equal 0. Okay, so you're going to have x squareds to deal with. You're going to have cosine and sine to deal with. There's a couple examples in there in your book, so take a look at those, okay? Just a quick note on functions. This will refresh your memory. This is a function because every x has its own y. This is not a function because the number 1 is an x but has 2 different y's that it goes to. Okay. We can also pass or fail the vertical line test. This one, fail, and we'll put epic. So it's not bud. Okay. All right. I know I'm moving fast. Feel free to pause and rewind and process if you need to, okay? That's why this is done. Okay, roots and zeros. We will get into this a lot more because these are importante. Okay, we need to get these down. Basically, it's a number c such that f of c equals 0. What do I mean by that? Let's try, there's an example in your book. Look at example 3. But I'm going to give you x squared minus 4. Okay. I need to find some number such that this is true to find the roots or the zeros. Okay. In this case, I will have to factor. Okay, I cannot just add. On this one, I probably could get away with it, but most of the time you need to factor and whatnot. Split them apart. X is 2 and negative 2. Those are my roots, or my zeros. Okay, those are the C's such that this is true. If I wanted to use those to graph, herein lies the reason we have graph paper, because it's really pretty. Negative 2 and 2. My y-intercept is negative 4. There's your graph. Okay.
So sometimes it makes it easier to graph. Remember that shape, x squared. And we have, by the way, translated it down 4 spaces. We subtracted it 4 spaces down. Okay. This function, okay, so we're going to talk about something called increasing and decreasing. So a function is increasing if as x goes to infinity, y goes to infinity. So we're headed that direction in the x, that direction in the y. So this is increasing here. Focus. Come on. Okay, now we should be good. It is decreasing as x goes to infinity, y goes to negative infinity. Okay, that would be x, y. So this is decreasing until it hits 0. Okay. Another way to put it is how the book puts it. I wouldn't worry about that. You just need to know the concept. Okay. For now, we'll just do the conceptual understanding. Decreasing, we're always going left to right. Decreasing, increasing. Got it? Now let's graph another. It's going to be imperative that you know the shapes of these graphs. You can just pop them off. We're going to work more with them, but this is just kind of an introduction. The next section is linear and quadratics, and then we go to the basic classes of functions. So the next 3, and then trig. So the next 3 lessons are focused on the shapes of these graphs. One way to do this is to do a table of values. I always start here. You get our outputs. This one's fairly straightforward. Might go to -2 and 2 just to make it obvious. This does this. Okay, that's y equals x cubed. It is increasing on the whole interval. Okay, this one's decreasing from negative infinity to 0 and increasing from 0 to infinity. Okay, I'm on a video, so do you need something important? Okay. Yeah. Yeah. Okay. I'll combine. Alright, so graph. Now, what if I wanted to translate that graph? X cubed plus 2. Alright, let's do this in green. Okay. Well, x cubed plus 2 moves it all up to everything. Here, 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 here. So I just moved it up 2. Okay, so that's a shift up. Okay. If I want to, I can also shift it left or right. So if I did x minus 1 cubed, okay, this is actually going to shift it right. counterintuitive because that is a negative one, but it does shift it right. So it takes this one right. Right, so anything inside the parentheses with the power shifts left or right, and anything outside it shifts it up or down. We can also stretch it horizontally or vertically. So if I did like, let's do a half. This is going to do what? It's a half, so it's going to crush it down by half. Okay, it's going to make it grow slower. Here's still 0, but here it's going to be 1 half and negative 1 half. This one's going to be negative 4. You see how it's kind of stretch or shrink it. Okay, you just kind of have to get those down. There's an example in your book. Example 7 is a good one with a sine function. And example 6 is a good one with x squared. Okay, so take a look at those. And let me know if you have any issues with it, okay? There's one more thing to talk about here, and that is even and odd functions. Okay, and this has to do with symmetry. All right. F is even if f of negative x equals f of x. Let me show you one. Let's do this one. Okay, if x is x squared, I'm going to test and what happens to a negative when you square it? It becomes positive. So they match. Yay! Okay, so f is even. Okay. F of x is odd if f of negative x equals negative f of x. Let me give you an example. Let's say g of x equals x to the negative 1. So I'm going to plug in negative x. Which in fact gives us, if you follow power rules, we can do it that way, which of course is negative of f of x, because you have f of x here with a negative in front of it. So, oh gosh, that's g whiz. So g of x is odd. Okay? There are, in fact, functions that are neither even nor odd. Okay, so you have to be careful there. Sometimes it's neither. It would hit neither test. Okay, it would just not get either test. I think that's enough. Here's the whole assignment. I only gave you part of it today, so I wouldn't overload you, but it's 1.1. Yeah, that's what I gave you today. Add on. Those. It looks like a lot of work. It is. Again, work on a little bit tonight. Get through a few of them. Come to class tomorrow. You'll have about 50 minutes to work. You'll probably have a video to watch tomorrow night too, so don't count on having homework time tomorrow night, but do what you can. We'll see you tomorrow.